So do you guys see the PowerPoint here?
Oh yeah.
Yes? Okay, good.
Yes.
So let's see. So cardiovascular basically is cardio means heart. Vascular means vessel. So this one is heart. This is blood vessel. Blood vessel. So they provide the blood circulation. They complete this circulation. This topic is very, very important. It's because that is related to the sickness, the death. The top three cause of death in America are stroke, cancer, and heart disease. Stroke in the brain, cancer, and heart disease. And the stroke in the brain and the heart disease are all related to cardiovascular system. So these systems basically cause the damage of this system cause the majority reasons of the death. So that's why this is important. And they can be, we will discuss it in two portions. One is the heart, that is the first one, and then we will talk about the vessel. The heart is this one. So in the beginning, let's talk about some anatomy. The heart, human heart has 4 chambers, right atrium, blood coming from the body go through the vena cava, superior from the top, inferior from the lower portion of the body. This vena cava is the vein. So this vena cava is basically the large vein, and these are non-oxygenized blood. There's no oxygen coming from the body into the heart. They go into first right atrium, and then right ventricle, and then go through the pulmonary artery to lung. From lung, it receives the oxygen, and then it go into the pulmonary vein, go into the left atrium, then left ventricle. From left ventricle, go through the aorta, then go to the entire body. So here you need to know anatomy, basically 4 chamber. That's what you need to know. Atrium left and right, ventricle left and right. And the second thing you need to know is the blood flow sequence. From the right atrium, right ventricle, left atrium, left ventricle. So that's the sequence of the blood. Later, we will also learn that there are valves between these chambers and the large artery. And so the valves include the tricuspid valves in the right atrium and the ventricle, pulmonary valve, the aortic valve, and the bicuspid valve from the left atrium to the left ventricle. So we have 4 valves, 4 chambers, and the blood flow sequence. So that's the key points that you need to know. Any questions?
So just know the blood flow.
Just know blood flow. Yes. Yeah. That basically is a, so you know that it's connected as a series. Right atrium, right ventricle, go to lung, left atrium, left ventricle, go to the body. So that basically goes through all these different steps and then go into the body. The next thing that we will learn is the heart muscle. So we will spend only 3 slides to talk about the heart muscle. So basically, this is an extension from the muscle that we just read. Cardiac muscle and the skeletal muscle has one thing in common. That is that both are called the striated muscle because they have a striated appearance. And they also have this actin, myosin. So basically their contraction mechanism is the same as the skeletal muscle. It means that calcium need to come in. The difference is that the calcium in the skeletal muscle, this calcium coming from the sarcoplasmic reticulum. From the sarcoplasmic reticulum. But in the cardiac muscle, it coming from the extracellular space. This one coming from in the muscle here, we have the sarcoplasmic reticulum, CA, calcium coming from this organelle inside of the cell. But in the cardiac muscle, it coming from the extracellular space. And calcium come in, remove the tropomyosin, actin myosin bind together to provide the power stroke. So that part is the same. One thing unique about this cardiac muscle is that they all connect together. So it means that, let me draw it using like an easier form. So basically that in the skeletal muscle, each muscle is separate. You will need the nerve from the spinal cord to send axon to excite each muscle. So each one is separate. This one need to excite by muscle nerve, this one by nerve, this one by nerve separately. So that is, this one is skeletal muscle. So this is the skeletal muscle. As for the heart, the heart muscle, let me just erase that one. I don't really need that one. As for the heart muscle, these muscles are connected in a way that, so this is the muscle connected. The entire heart, all the muscles are connected. So when the nerve or when the action potential travel excited one heart, it will travel along the membrane to the next heart, to the next heart, to the next heart, to the next heart muscle. So when they contract, when they got excited, when they contract, the entire chamber, the entire heart will contract all together. It's not like our skeletal muscle. Our skeletal muscle contract by the unit of motor unit. So each motor unit, all these muscles contract together. But in the heart, the entire chamber muscles are contract together. So if we look at this anatomy, this figure, we can see that this is one muscle, and here is they have called a gap junction. So this gap junction basically allow this action potential when it travel in one membrane, it will propagate through it to another muscle. So all the muscles are connected together. Muscle will also, so that basically is the key point here. Any questions? So remember that, okay, so just keep it in mind. We will talk about this.
So
Yes.
Professor, So in this case, it doesn't require a lot of motor unit, just one
No,
unit
no.
to take care of it.
Yeah, so they only need to excite one cell,
Okay,
then the entire group got excited.
okay, all right,
Yeah.
thank you.
So basically
And that's
that's, if we later we will learn about the electric conduction, we have the SA node, the AV node.
Okay,
SA node, when SA node is excited, the whole left and right atrium got contracted, got excited.
okay,
So it doesn't have to send nerve into each muscle, because once SA is excited, the whole atrium ventricle got excited.
all right, thank you.
When AV is excited, the whole ventricles got excited. Okay. And the next thing we must know is that the action potential of the cardiac muscle cells has a little bit different feature than the other action potential. So here is the action potential. So a typical action potential has two phases: depolarization and repolarization. This is depolarization. This is repolarization. This one opens up which channel?
sodium.
Sodium.
Sodium potassium.
Yeah.
Sodium open up sodium channel. This one opens up potassium channel.
Yes.
It can complete this action potential. So this is a typical action potential. But in the heart, is in addition to the polarization, in addition to the depolarization, that is this one here. That's this one here. And the repolarization, that's this one here. So basically this part, these two phases are equivalent to the typical action potential, depolarization and the repolarization. In addition to these two, it also has one extra phase. This phase is called a plateau. Let's see if I can find the plateau. Where is plateau? Here, during the plateau. So this phase is called a plateau. So here we have the depolarization, plateau, and the repolarization. Depolarization, the sodium channel open. Repolarization, potassium channel open. During this plateau, the calcium channel open. And the calcium influx to allow the actin to bind with the myosin to complete this power stroke. So that's the action potential of the cardiac muscle. The unique feature is this plateau. It has this influx of calcium into the cell.
So during that plateau, is that when the heart is like holding its contraction?
Yes.
Mm.
Yes. So calcium coming in, the heart, basically this one, basically that during this period of time, the entire chamber. So here we have the atrium, ventricle. During this period of time, is about, this is 20 milliseconds, is about 0.2 seconds. During that 0.2 seconds, the entire atrium contract.
Mm.
And following that is another action potential. So here is one action potential, sorry. Here is one action potential from the atrium, and then following that is another action potential from the ventricle, cause heart to contract. Any questions? Do you need me to, like, which part is not, is there any parts not clear? So
Yeah.
basically that, yes,
So
please.
for repolarization to occur, the heart has to go through phase number 2.
Yes,
Okay.
yes. So
All
this has to go through phase 0, 1, 2, 3. Yes, 4.
Okay.
Yeah.
So that's the break between the atrium and the ventricle.
Yes.
Okay.
Second?
I said the plateau.
Yes.
I think is if I might use the word, the delay
Yes.
between the atrium and the ventricle as
That's,
action potential travels.
that's right. So in the atrium, there is this one. Following that will be another action potential in the ventricle.
Okay. All right. Thank you.
And during this time, as Rex said, calcium coming in, during this time, the atrium contract. During this time, the ventricle contract. This calcium coming in.
Right. So both contracting. The atrium and the ventricles are both squeezing during the plateau. Is that what you, or the atrium? Just atrium only.
So the action potential, when action potential travel in the so here is the atrium and the ventricle. The blood coming into the atrium, going to the ventricle, and then from the ventricle going to the body. Just make it simpler. And so the action potential, when it's travel, it will travel through the entire atrium because all these atrium muscles are connected. And then it will stop because atrium and ventricle are not connected.
Right.
But the SA node will send signal to the AV node.
Okay.
Then AV node will be excited. When it excited, it generates another action potential. This action potential will travel across the entire ventricle because the entire ventricles are all connected.
So Professor, when the atrium contracts and then it goes through like the process of 0 to 4.
Yes.
When the ventricle starts contracting, does that mean the atrium will stay in phase 4?
Yes.
While the ventricle contracts?
Yes.
Okay, okay.
Yes. So atrium will take about 0.2 seconds from 0 to 4, about 0.2 to 0.3. And the following that will be ventricle, which will be very much the same, like 0.2 to 0.3. So overall, this contraction take about 0.4 to 0.6 seconds. So from the atrium contraction to the ventricle contraction. And do you know how much time it will take between each heartbeat?
Like a fraction of a second?
Something like a second, right? Because say heartbeat is 60 beats per minute.
Mm-hmm.
It means that each beat takes a second.
That's if you're healthy, right?
Say again?
That's if you're healthy.
Yeah. So say a second. It means that during this contraction, it will take 0.4 to 0.6 seconds, and then there will be another like 0.5 seconds of resting because the entire cycle will be about 1 second, something like that. Does it make sense?
Mm-hmm.
All right, I will, should we just stop here and we can continue next one?
Yep.
The next,
Sounds good.
All right. So before I let you go, I will want to go through the lab, because this lab need to be turned in. Did you get the lab note?
The lab note.
Yeah.
Yeah.
Is it in the email or on Canvas?
On Canvas.
The EKG thing?
Yes.
Mm-hmm.
The EKG one.
I don't see the actual assignment.
It's in the folder.
It is on Canvas. The note is on Canvas file. In the file folder.
Oh, the online lab. It
Yeah.
says online lab as the tab.
Yeah, online lab. That's right.
Oh, okay.
When does this due?
Tuesday. So next Tuesday, say before, try to submit it before the lecture or before the Monday night. Submit. So by next Tuesday, I will need to see your weekly report as well as your lab report. So two things by next Tuesday. So let me
On the 14th.
On the 14th, that's right.
If we don't have access to a printer, can we just like?
You don't have access to Canvas?
No, to like. So are we supposed to print it out, or how do we? Because I don't have a printer.
Okay, printer. Okay, so you can you know what? You can just skip everything, but just work on the final. Let me pull this page out so I can provide you some guidance here. Let's see. We have here. Sharing.
Some stuff I might be able to do, like if I open it in a Word document.
Yes. So let me do it here. Okay. So let me see.
I've used Doc Hub, and it lets you edit PDFs, and it's totally free. It's Doc Hub.
All right, did you guys see this the Word document here?
Yeah.
Okay, good.
Yes.
So here is this note. Let's go through it, shall we? Okay, so basically this is about the EKG. EKG is a method to detect our heart function. So if we look at the EKG, basically it looks like this. So this is a typical EKG. EKG has typical waves, including a P wave, QRS, and a T. Don't worry about this V wave. This is not very noticeable in most of the case, but this P, QRS, and the T are very noticeable. So this is one heartbeat and then the next heartbeat. So this is a typical ECG and EKG are the same thing. So you can see sometimes people say it as the EKG, sometimes people say it as an ECG. C refer to the cardiac, cardiograph, but C could be K because of, the all time. And so basically here in the very beginning, go back to the question that in the very beginning that you have to this kind of like an introduction about some important properties of each EKG. Basically that cells are excitable, heartbeats are automatic, means that SA node and AV nodes are the pacemaker. The conductivity means that this conduction can conduct from SA node to AV node, and then the entire heart. So this is the electric conduction. When it excites, when it transmits to the SA, it will cause both left and right contraction because atrium, both left and right, are connected. So this potential travel to both left and right to cause contraction. Then AV node travel to both left and right ventricle, then cause ventricular contraction. And this one will generate the atrium contraction, squeeze blood into the ventricle to both left and right, and the ventricle contraction. The contractility is the heart contraction. Refractoriness means that this heart contract and then they won't immediately get contracted right away. And so that is this, basically some background about the EKG. And then it goes through this principle again, the automaticity that the pacemaker. Be honest, we will talk about this one over again in our lecture in the next in this week and next week. So, but for the lab, we just read through it, kind of like give you guys a preview for our lecture. And then here is the EKG. EKG has when we conduct. Have you guys did the EKG before?
Yeah.
Yes.
Okay, good.
Yeah.
Okay, so you know that in the lab, if we are in the lab, if we go back to the lab, we will put the person on the table and put legs all over the body to collect this wave. And so we will get the lead 1, lead 2, lead 3, AVR, AVL, AVF. This is not AVL, AVF, should be AVL, AVF. You know what I'm saying?
Yeah.
Okay, yeah.
Yeah. The exam table, and then you connect all the leads.
Yeah.
You do the reading.
Yeah. Okay. So and then we will get the when we collect all this will be drawn on this piece of paper, and then you slide this paper in the machine, and the machine will run and start to draw it, to draw this on the piece of paper. And then we will do analysis. Basically, we need to identify these three important waves. P wave. P wave is the atrium, depolarization, contraction. QRS is the ventricle, depolarization and the contraction. T is the ventricle repolarization. Don't worry about it. Even if you don't understand it, we will talk about it. But basically, that's atrium ventricle contraction. And then you need to identify these waves, identify the P wave, QRS, and the T. Something important is the PR interval. This PR interval refer to the delay of the action potential from atrium to ventricle. So PT interval, PT segment is here. This is T. Usually this ST segment is important to see whether this heart has the damage. If there is a heart attack, we usually see the elevation of ST. So you just need to identify whether it's flat. It should be flat. If it's not flat, then the patient has some heart disease.
How do you know when there's an infarction?
Yes. So how would you know there is? So ST segment If if it is elevated, then this patient has infarction. Yeah.
There should be no peak there, right?
There should be no peak. Yeah. It should be flat. So that just basically that here just provide you a normal, healthy, like typical ECG. And then some rule to see it include, let me see, what's that? Interpretation of the rhythmic means that if you have the if you have the EKG, right? Okay, sorry, P, Q, R, S, and the T, and then you have the P, Q, R, S, and the T, and the P, Q, R, S, and the T. If they repeat regularly, it will be a good rhythmic pattern. If not, then it's irregular. So basically we put this measure throughout, say, a minute, and then we will collect about 60 bits, 60 waves, and then we see how distant these waves are placed. So that's that one there. Close this one. And then it give you some, erase this one. So it gives you some idea about the 3-second method, 6-second method. Basically, this one is to quantify the heartbeat, BPS, beats per minute, BPM, beats per minute. RR method is also to quantify the heart rate, beats per minute, BPM. Okay, that's that one. And then, so basically you read through that, kind of give you guys some background, and 5 cardinal rules. You need to know these 5 rules, basically to kind of like very basic principle, rhythmic. See if we look at the EKG, we need to see these 5 as the major important, like first thing to see. See if it's regular. See if it's about 60 to 100 beats per minute. So that heartbeat will be in the normal range. If you see it too high, what does it mean? If the beat per
Inadequate blood flow.
Yeah, so inadequate blood flow, and the reason that BPM or the heart rate increase is the sympathetic most of the time. So you can see that you can assume that this one has low blood flow or low blood pressure, and the baroreceptor in the aortic arch and in the carotid body will detect that low blood pressure sent to the brain and to excite the sympathetic nerve to increase the heart rate. So this is related to what we learned in the very first lecture of the homeostasis. The sensor is the baroreceptor. The response, it detects the blood pressure. The response is the increase of the heart rate. Do you guys remember that? That was like before.
Of course.
Yeah.
Yeah.
So the and also, so that's important. So see if the rhythmic, see if the heart rate is in the normal range. So here is a concept that you need to know what's normal range. 60 to 100 beats per minute, that's the normal range. And also PQRS. Basically, this one is you need to have 1P, 1 QRS, 1P, 1 QRS. That's because you need to have atrial contraction followed by ventricular contraction. And atrial contraction, so when you see the the wave, you should see something like this one here. So you must have, in the normal situation, you should have P, then QRS, and a T. And then this one will repeat over and over again. But if you see something P, QRS, and then there is no P, then there's another QRS, and then another QRS, and then and then you have P, QRS. So P, QRS is not 1-to-1 ratio, because here you have QRS, no P. No P. If you see that, that means that your SA node to your AV node is not connected. So you don't have the P, you only have the QRS. You don't have the atrial contraction. So this one will mean that the cardiac block. So you need to have that PQRS is 1-to-1. You have 1P, 1QRS, 1P, 1QRS. PR interval is also important. That's why we keep mention about it, that the atrium, sorry, the action potential is about 0.2 seconds, and there is a delay. So this is atrium action potential. This is ventricle action potential. So the delay is about 0.2 seconds. That's why we have the PR interval about 0.2 seconds. If it's longer than that, then there will be another block. So that's also important. QRS must be small, about 0.04 to 0.1 second. So that's the rule. And so let's move on. That will be that. And then you know, go back to Caitlin's question. If you don't need to print or even like a
That last page.
That's the last page. And you can just answer this question, because in the beginning, it basically provide you, this is very much like in the lab, because we are not in the lab. And in the lab, we will have one people to get the EKG. That is this one. And then the other person would go ask him to run post exercise, you know, on the back to get another EKG. And then you have this data, and then you answer all these questions. So basically, you just need to have the very last page. Just answer this question. That whether they have a good rhythmic level, what's their beat per minute, something like that. So that's that. Any questions? So basically, that's the EKG, and the case that we are studying is a resting person versus a post-exercise person. And very immediate, we know that the exercise will increase the heart rate, and we can review, we can detect or measure that heart rate by using EKG. Yeah.
I just feel it's such a disadvantage because I'm not in the lab, you know.
I know, right? I very much feel like
So have empathy when you're grading, please.
well, the thing is that we don't have the exam. That's the biggest emphasis. I cannot give you lower grade. I have no, but yeah.
It's okay. You want higher grades.
Exactly.
Students are excelling.
That's all we do is high grade. Everything's high grade.
Amen.
Yeah, Professor,
Think about it.
90% is okay.
90% is okay. 90% is an A. Come on.
Oh, that's why I say I'm not asking for 100. At least not 90%.
100 and 90 is the same thing. Okay, it's all A.
All right. So I think we'll be fine.
Yeah.
So you're saying we can all get an A?
Yeah,
No.
that's what he said. He said we're all getting A's.
A?
So the grading will be it's my idea is that I will try to maintain like a normal distribution. If you submit it in a good quality, you will get 7 and up. And so in only those the top say 4 or 5 reports that's considered like outstanding.
My report.
Get, like, but the majority you expect to see like 7, 8 range.
Oh, wow.
Hmm.
Well, what if everybody's report is outstanding?
I kind of feel like maybe by the end of this semester we will reach that.
Woohoo!
Yeah,
I like that.
Yeah,
We'll get a full 10?
because I can see that there is basically this is the beginning of our online, or the start of the beginning of our online class. And I just got your weekly report, and there are some rooms that you guys can improve. For this weekly report, one thing important is that don't write like a small essay, because you want to, when you study this, you want to be able to only focus on the kind of like condense it and to organize it in a way that you emphasize key points. Because say you think that say a month later or like a year later, you are going to go to a big exam. You need to review the skeletal muscle. You don't want to read an article. You want to be able to quickly read through and pick up these key points. And very quickly, like take a second or two to quickly build, to refresh your memory about it. So the way you organize this summary note, you need to put your emphasis on the terminology. You either drawing or writing or using color to put everything center on the terminology. But don't write a story. Don't write, this is not about the essay. This is about that, how you kind of like process all this information, knowledge, basically, all this knowledge into a short, condensed piece of paper. And so I think, what the thing is that when I read you guys' summary note, I feel there is a correlation that some people that do good in exam also do pretty good with this summary note.
Thank you.
So, yeah. So
Appreciate that. I felt like you were talking to me directly.
So there is a room. I want you guys, don't try to write. You need to process it and then make a note that's for your own, like review, your own summary note.
So do you suggest like an outline instead of like an essay format, or?
Instead of essay format. Essay.
Damn.
Yeah.
Are bullet points okay?
Bullet point is okay, but so there is two extreme. One is like a article. Article is good, but not good for exam. Another extreme is like a flashcard. So say you have the flashcard. Let's say it's very directly targeting the exam. You have the flashcard that questions, answer, question, answers. But I don't want you to build a flashcard because there's no connection. Flashcard, the disadvantage of flashcard is that you have piece of information, piece of knowledge, but they are not connected. And it's very difficult to memorize a thing that is not connected. You need to connect this together, but you don't want to become like a big or like a long like essay, and you don't know what's the key points there. So that's you need to kind of move from the essay type of the writing to the flashcard, but not to the flashcard that's all like a broken apart and you don't build the connection. You need to connect them together, but you also need to emphasize each terminology.
Can you give me feedback after you look at mine and let me know?
Sure, sure, I do that.
Yeah, I would like the
Appreciate
same
it.
actually.
Yeah, I saw Eddie's report. I didn't read it yet, but I just saw it. It's kind of like a good kind of like report. It has
10 out of 10, I told you.
Man, there he goes, blowing his head up now.
Like a 9. You're getting a
Yeah.
9.
I have not read it yet,
I
but
told you.
something like you need to focus on the because when we learn something, a new field, when you enter into a new field, the most important thing is the terminology. And you need to put that into the center of your summary. Yeah. So this is the first one, and you will gradually improve. And through this process, you will learn how to do it. And I can expect that you guys will get a better grade later on. Okay. Eddie, I haven't read it. I just feel like it seems like a good example. And
It's a bunch of chicken scratch.
Can you give us an example what you want for the next assignment? Because I can make like a
let me read Eddie's first, because if he takes to show, I don't want to show that I need to get the permission first. But the thing is that no matter what kind of format that you do, you need to emphasize. I want to see that you emphasize the terminology. I know that some people use typing, which is also very beautiful. That someone use hand drawing is also very beautiful. But I want to see that you organize in a way that there's a bullet point. This is the key terminology, and how would you connect all this key terminology together? All right, then. So that is it. Any questions? You guys doing good?
Yeah, heck yeah.
When do we get the report and the feedback back?
I will do it today or not today. Today is late. Probably tomorrow. Probably tomorrow. And I'm actually working on a short like email to give you guys like a overall feedback that you can, because I didn't know that what I got, but now I know that this is what I got, and I kind of feel like some of you guys have very similar pattern that can be improved. I won't say that it's not right. I won't say that it's not good. You need to improve it into the way that you can build your personal like a thing based on your own like preference.
All right. So I just to say something real quick. I had another instructor that wanted something similar.
Okay.
He wanted you to own the material,
yes.
Which meant like just taking what is in the slide and then you putting it basically in your own words. And that's pretty much what I did over here. Did like my own little drawings, even though I can't draw for crap. I can put them up. I'll put them up on a discussion board, and then you guys can talk crap about it.
All right,
Sounds good. Yep. All right, guys. So if there's no other question, I will see you guys Thursday then.
Okay.
Okay, good.
Sounds good.
All right.
Bye.
Thank you, Professor.
All right, thank you, guys.
All right. Thank you, Professor. Have a good day.
All right, Professor.
Yep.
Take care.
Bye.
Thank you.
Take care, everybody.
All right.
Keep on drinking. That soda.
Apple juice. It's apple juice.
Oh, apple juice. Sorry.